Hello everyone. So welcome back. So today again we are going to have one more problem on array. Find all duplicates in an array. So this is pretty straightforward, very common problem which we know, and today we will solve this particular problem. So what does it mean? The problem statement is like find all duplicates in an array. So given an integer array nums of length n, where all integers of nums are in the range of 1 to n, and each appears at most twice, return the array of all integers that appears twice. So for example, if this is an array, so you see here 2 and 3, they appears twice, so need to return 2 and 3. Similarly over here 1 is returned because 1 is repeated twice. So this is pretty much very simple and straightforward question to understand. Let me quickly go and just start and writing the code. Guys, if you remember and watch my previous videos, I always follow a fashion or style of coding any particular problem and eventually coming to a solution. Is that whenever the question is asked from any interviewer, you have to, discuss. The very first is like brute force. Never code the brute force, just only discuss about because that should be the triggering point of your solution. So I would like to definitely touch the brute force solution and then jump into the code which will be connected to the optimized version of the problem. And I just create a class which is find all duplicates. Okay, find all duplicates. And now I add the class level comment as I always do. And let me comments from here. This will save my time to copy paste the uh, input and output. This is my, and now I have my main method, and over here it's my input. I always follow this fashion, logic and then output. So here we go. What is input? So input is nothing but an integer array. So int nums equals to, and this is my int array. So I'll take this array. All good. This is my int array. And now when it comes to logic, so it should return me the list of all, I mean an array of, so I would say list because I'm using Java, and I would say integers. So this is list of integer, and let's say it's like duplicates, to give it duplicates, and then find duplicate. Okay, and here I passed nums. And then at the end, I just need to print out my duplicates. So this is pretty much, on a very high level, the solution. Let me import the list. So now let's discuss about the solution. So the very first thing which comes in my mind is like, okay, how we start and thinking about the problem and its solution. So it is asked to find the duplicates. So it's very simple, right? Because this is an array, you have to find duplicates. So any element, you can have your two loops. So one is the main loop, which will iterate and pick every index, and the other loop inside it will be comparing the element at I is equal to 0 with all the elements into the array. And if you found uh, within the nested loop, then it will give you checking the pairs. If it is found, then it is going to be the result set. So for example, if 4, you started with 4 and you just iterated the whole array, so I is equals to 0, which is 4, and j will start again, the nested loop will start again from 0 to, or let's say I plus 1 to the size of the length. So it will compare 4 with every single element, and then if it is found, then it means you can add because it is coming twice on duplicate, otherwise not. And then result array will be the final answer. That is one way. But there, when we are talking nested loops, it is O of n square time complexity, right? So can we do it like in place with, let's say, O of n time complexity? Yes, we have a solution. So um to have this in place marking, we need to understand the fact. uh, so elements in the array, they range from 1 to n, right? So that is already given in the problem, and that is the reason why you also have to Sometimes look at the constraints, because which is very important. So all the elements into the array, they are ranging from 1 to n. Okay, and that is the deciding factor. Why? So let's say for each element num I, we can calculate its index. Okay, so the index would be, we can just say that for any element num I, okay, uh, we can say that its correct index would be index of, absolute value, maths dot absolute value of nums of I, and then -1. Okay, so whatever element value we have, so for example 4, okay, this is 4. So can we found at index 4, which is actually -1, because when you say anything, any element into, when you talk about indexes in an array, it's like always -1 because it starts with 0. So let's say we are talking about 4 as an element, and since all the elements are between 1 to n, so we will take the advantage of having this indexes, right? So nums of I, which is 4, okay, -1 is 3. So what is the value at what is the value at 3? So 0, 1, 2, 3, it is 7. So that means we can easily find out basis the element value and calculating the index from there, and then we can understand from that particular fact that, say, let's say if we are marking num of index is already negative, okay, uh, because we have to always mark that particular index. So if it is already negative, it means we have seen this element before, right? Because we will be marking it negative. And then we can just say index plus 1 to the result, right? So that will give you the value which appears twice. So if not, if the value at that particular index is not negative, meaning nums of index, okay, is not negative, it means this index has been visited, right? So that is the way on a very high level, which can give us an idea to play around with the indexes, and then comparing all those elements in place. So let me quickly code the solution, and then maybe when you see what I'm writing in, it will be more clear. So I created this particular method, and now I just go into this. So as I said, I will be having my list of integers. All right. And let's say I say it's cell result, and then new array list. Perfect. And then what I'm doing, I just need to iterate on my nums. So int I is equals to 0, I less than nums uh, dot length I plus plus. All right. And then int of index is equals to math dot abs, and then nums of I, and then -1. All right. So what does it mean? We are taking the absolute value, and we must know why. Why we are taking the absolute value here? Because uh, in order to find the correct index corresponding to the value which is at nums of I, we have to understand the fact that, let's okay, so given that an array of integer where each value ranges from 1 to n is the length of the array, right? Each number can be uniquely mapped to an index in an array. So for a value, let's say x in an array, the corresponding index would be x minus 1, right? Because arrays in the Java, they are 0 based. So now using absolute value, uh, so this particular algorithm, it modifies the array by marking visited elements as negative. So we use math dot abs nums of I, because you are what you are doing. You are reusing the concept. You are trying to do everything in line. Moment you get particular element, you find the index and then mark that particular index as negative. So next time when you pick it, so it will ensure that even if the value has already been marked as negative, we can still retrieve the original index. okay, with that particular value, and that is the purpose. So by accessing nums index with this way, we can check if the element at that index has already been visited, and if nums of index is already negative, it means we have encountered this value before, so it is a duplicate. If nums of index is positive, we mark it as negative to signify that this value has been seen, and that's the whole logic which lies here. All right, so this is the index, and you know why we are calculating this absolute. Now we just need to do nums of I. If it is less than 0, it means if it is negative, what does it mean? It means that this is a duplicate because that has already been visited. Nums of no, we have to play around with indexes because indexes are now the real values. We already use indexes for the values. Index plus 1, because you see here we did a minus 1, right? So this was the reason. And now when we say else, it would be simple nums of index, and we mark it as negative of nums of index. Okay, so this is what we are marking here. So I'll like repeat it again one more time just to understand why I'm doing all this. Okay, let me do it this way. Return result. All right, so let me explain these two lines. So what I'm saying if nums of index is already negative, okay, that means we have already encountered this value before because we made it negative, right? If nums of index is positive, we make it negative, and that's pretty much all. And over here, index is already always with maths dot absolute value because we are making this as negative. And this is pretty much all. And at the end, you should have the final result. Let me run this particular problem quickly. So you see here 271, is that the expected answer? All right, 271. So 2 is duplicate, 7 is not. Okay, there is something wrong. I need to check what's wrong. I is equals to 0, I less than nums dot length, perfect. Index is equals to maths dot nums of I minus 1, perfect. Nums of I. Okay, I'm sorry, this should be index. Nums of index should be less than 0, and then index plus 1. Okay, let me run it again. Here we go, 2 comma 3. This is the right answer. And then let me put it 1 1 2. So I just change it to 1. Okay, 1 1 2 and run it. 1 is the answer, which is correct. And if I put 1 only and run it, I'm getting a blank array. So to me, answer looks good. Let me copy the solution, paste it here. To copy and paste it here. Because I'm using here some Java utility, so I just copy these two statement as well because this is needed. Otherwise, this will not run. I run this particular problem. Okay, so it's running. Accepted. Let me submit this solution. Okay, all good. That we started the problem discussion with the brute force where we were talking about two nested loops. One will be I is equals to 0, taking every single element at a time, and then j would be comparing that particular ith element with all the remaining elements into the array, and wherever we found duplicates we were adding into the result array. And second was, whenever you found duplicates, you can play around with the real indexes. Time complexity and space complexity, let me add it quickly. Time complexity, of course, this of O of n because we are doing it inline. When it comes to space complexity, it would be O of 1 because it's fixed in size, right? We have not taken anything extra. So that's pretty much all. Uh, it's pretty much all that has been um, the solution for this particular problem. I see you in another video. Thank you very much. Bye.